All right, so here in this video, we are solving for a variable. So what we're going to do is the same algebra that we've been doing when we solve equations. You know how like when we solve equations, when I have, let's say, I don't know, x plus 3 equal to like 13 or something, right? You would see this plus 3, so you would subtract the 3 on both sides, right, to cancel it out, and you would simplify it. Well, those algebra steps are the exact same thing that we're doing here, okay? So none of the math is new. The only difference is instead of working with a bunch of numbers, we're working with a bunch of letters. But don't let that fool you, because in some cases it can be a little easier than actually having to work with numbers, in the sense that you don't have to simplify a bunch of letters. However, you do have to simplify a bunch of numbers. So that's the argument I would make to say that this is probably easier than what we've done in the past, but it can be a little challenging at first because letters freak people out, but it's no different at all, okay, than working with a number. Now, just to prove my point, to make a comparison, I'm going to solve these two equations. So the left side is one with numbers, and the right side is one with a bunch of letters. But the math for both of them is very similar and pretty much the same. So if you look at the one on the left, your goal to get x by itself is to get rid of this 6. Now, because that is 6 times x, to get rid of the 6, we have to do the opposite of 6 times x, which is dividing. Dividing by 6 is the opposite of multiplying by 6. That's what's going to get it to cancel out so that the x is by itself. And on the left side, 42 divided by 6 simplifies to just 7. We have our answer. Now, the one on the right, the one with all the letters, this is a volume equals length times width times height. Now, we're going to solve for h. So my goal is to get the h by itself. So therefore, to do that, I have to move the LW. If the LW is gone, then the h will be by itself. So just like I looked at with the 6, right? When I looked over here, I said, okay, that was 6 times x. So the opposite of multiplying by a 6 would be to divide by a 6, and therefore it would cancel out. And I think the same thing here. I think, okay, here's LW. What kind of math is going on with LW and h? Now, normally we would take one letter at a time, but because all of this is crammed together, we can actually do the LW at the same time. Both L and W are being multiplied to h, just like 6 was being multiplied to x. So the opposite would therefore be to divide. So when you divide by LW, you will cancel L and W both out. But of course, just like you did it with the 6, you have to do it on both sides. So if I divide by LW here, I have to divide by LW here as well. It kind of looks like 1W, but it is LW. So when that happens, the LW over on this side are all gone. We are just left with that H. And on the left side, well, we can't simplify it because none of those letters are similar at all. So we just leave it exactly the way it is. It is just simply V divided by LW. And there's your answer. Height is equal to the volume over the length times width. So the algebra is the exact same. You see something that's being multiplied to your variable, so you divide by that to cancel it out. Now, the only difference is on this problem, you actually had to simplify it. You actually had to know what 42 divided by 6 was. Here, you don't actually have to simplify anything. You can just leave it as a fraction because there are no numbers. There's no way you can simplify it. So when we're going through these problems, just look at them and keep in mind that you're just rearranging the letters, really. None of the letters are going to disappear. None of these letters are going to, or I should say variables, but people just trying to make it easy for you. None of these letters will disappear. We won't add any new ones. I still have the V, I still have L and W and H. All of them are still there. It's just rearranging so that I can isolate one of those variables. In that case, I was isolating H. So here, it's the same problem essentially, but you're solving for L this time instead of H. So it's very similar though. There's your L. So we need to get rid of W and H. And just like before, W and H are being multiplied to L. So since they're being multiplied, the opposite would be to divide. That will be what cancels it out. So I'll divide both sides by WH. What happens on the right side is the W is canceled, the H is canceled, so I'm just left with L. And on the right side, I'm dividing by WH. So I just have the volume over WH. Again, I can't simplify that, so I just leave it exactly that, and there's my answer. Okay. So it's just rearranging letters. You do the same math. You look at, hey, I'm multiplying something, so I need to divide by it to cancel it out. Or if you see you're adding something, you will subtract to cancel it out. All right. So let's look at a word problem real quick, and then I'm going to get into some other formulas or some other rearranging equations. So we have a formula for density equals mass over volume. Lead has a very high density of 11,340 kilograms per meters cubed. Plastic foam has a very low density of 75 kilograms per meters cubed. The volume for density can be rearranged to solve for V, the volume, or M, the mass. So that's just a bunch of information that we're going to need to solve this question. Here's our first question. A sinker on a fishing line is made of lead and has a volume of 0.000015 meters cubed. What is the mass of the sinker? So it's asking me for the mass, right? What is the mass of the sinker? So what I'm going to try and do is isolate M real quick. So to get this M by itself, I need to get rid of the V on that side. Now, since V is in the denominator, I know that that means it's dividing by V. So to cancel it out, I have to do the opposite of dividing by V, which would be the multiply by V. So what I'm doing is I'm multiplying V on both sides because I can't do it to one side without doing it to the other. I have to do it to both to keep things balanced. But multiplying by V and dividing by V on that side, that's just there to cancel out, so the M is by itself. So multiplying by V is simply canceling out the fact that we had dividing by V. Therefore, the M is alone now. And on the left side, we have simply V times D, volume times density. So V times D. So our mass is equal to the volume times our density. Now, we're actually going to solve this. We actually need to plug numbers in to figure out what the mass is. We know this. We know the volume. The volume of our fishing sinker on the fishing line is this number. So our volume, so this is going to be for V. Our volume is 0.000015 times the density. Now density, remember, it's made of lead. And it says up here, lead has a density of 11,340. So I'm just plugging these in. That's V, that's D, and we're multiplying them together to get my mass. So if you multiply those together, you get, I think it was 0.1701. I could be mistaken there. I don't remember exactly what it was. But just multiply them together and you get your final answer. Now the second part of this question, this same information as the last problem, but here's our new question. The design of a life preserver requires 0.3 kilograms of plastic foam. This is the mass of our plastic foam to provide for proper buoyancy. What is the volume of the plastic foam required? So it wants us to find the volume. Remember, the formula is D equals M over V, right? So if I'm going to solve for volume, well, then I need to get this V by itself. But it's not as easy as it was in the previous problem because we can't just get rid of M and move it over here. If we tried to do that, V would still be in the denominator. We would still have 1 over V if I kicked the M out. So I can't just do that. I can't just kick the M out. What I need to do first is get V out of the denominator. Now to do that, we do what we did in the last problem, right? The only way to get this out of the denominator, because that means it's being divided, is to multiply by V. By multiplying by V, it's the only way I can get it out of the denominator. But by doing that, I'm essentially moving V to the left side. So I have V times D equals M, which is what I had in the last problem. So I'm not really doing anything to that's making me really any progress because I don't have V by itself. I moved V, but it's still not by itself. But it's still a little bit of progress because now v is not in the denominator. I'm still trying to get v by itself though, because my goal is to solve for volume. So I do need now, because v is over here with d, I do need to try and get rid of d. And since that's being multiplied, dividing by d will cancel it out. So we'll have v equal to m over d. So it was we kind of had to go through a two-step process there. We had to get the v out of the denominator first. And when we did that, it moved to the left side, and that's totally fine. Once we've gotten it out of the denominator, we were able to isolate it by dividing by d, so that it would be by itself. Now, I just want to point out the fact that our original problem and our new problem are essentially the same thing, except d and v are kind of reversed. And that's cool. That's just what happened. It's reversed. They kind of just flipped roles because we did the opposite things to each of them. We multiplied by v, so that moved it, and then we divided by d, and that moved it. So they just kind of rotated roles because we did opposite things to them. But anyway, we still need to solve for v. So we need to plug in our numbers. We need to plug in our mass. We need to plug in our density. Our mass is 0.3 kilograms. So we're just plugging in 0.3. And now we need density. Now this is for plastic foam because it's a life preserver. Our plastic foam has a density of 75. So we're just doing 0.3 divided by 75, and that is 0.004 as an answer. And that is our mass. No, that's our volume. I apologize. Okay, I'm going to skip these few word problems. I might do them in another video, but I just wanted, for the sake of this video, to show you what we did in class, which is these problems here. We solved all these different equations, just practiced rearranging formulas. So here in this first one, we're solving for m. So what we're going to do, let me actually just write it over here so I have a little more space. Okay, what we're trying to do is solve for m. So to get this m by itself, right, I'm going to need to get rid of x, and I'm going to need to get rid of b. Now, since x is attached to m right now, it's a part of that term, I'm going to save that for last. So the first thing I'm going to need to do is move b, and then I'll move x later. Now, since it's plus b, right, you do the same algebra, right? Just like anything else. If you're adding b, the opposite of adding b would subtract b. So minus b on both sides. Just like if you had an equation where you're adding 5, you would subtract 5 on both sides. It doesn't make a difference if it's a number or a letter. The math is the same. So when you subtract by b, what you're doing is you're canceling that b out. So you're just left with mx over there. Right? The b's gone. It's just mx on the right side. On the left side, be careful what this says. That just simply says y minus b, because remember, you're subtracting b. So we can't combine those. We can't simplify it. We just write it as we read it. It says y minus b. It is y minus b. So see, all we did in the first step here was we moved b to that side of the equation. And by moving it, we had to do the opposite, which was subtract. So the b is on this side now, but it's just minus b instead of plus b. But now I'm still trying to solve for m, so I still need to get rid of x. So since that's being multiplied to m, to get rid of it, I would have to divide by x. Now, I'm going to be dividing that right side by x so that the m is all by itself. The x will cancel out and go away. We'll just have m by itself. On the left side, I'm dividing that by x as well. But again, there's no simplifying. It just says y minus b divided by x. And that is exactly what our answer will be left as. Y minus b divided by x. Seems not, it doesn't seem like it would work, but that's the way it is. You can't combine those terms. You can't simplify those terms. So again, all we really did was just take these letters and rearrange them into a different format. It's still y, mx, and b. It's just rearranged in a separate way. Okay, and we only did 2 steps. We had to get rid of plus b, so we subtracted. We had to get rid of times x, so we divided. And that's it. And you can see we subtracted the b, we divided the x, and we're all set. So now let's look at the second problem here. So solving for c, we have ac plus bc equals 36. Now this one's unique because we're solving for C and there's 2 of them here. The only way we can get C by itself is if there's obviously just a single C. We can't say C and another C equals whatever. It's just we have to have one C. So what's going on here is something based on the distributive property. You know how when we have the distributive property, if I had X and I had X times 3 plus 5, for example, and I were just asking you to distribute, you would do X times 3 to get 3X and X times 5 to get 5X. So this is essentially the same thing as this. Well, we're going to do the opposite. You see, in this case, we already have, it's kind of already post-distributed. It's already been distributed. Imagine here, going backwards. What you would do is you would take the X's out and you would move them back in front. And then you would leave the 3 plus 5 behind to get this, right? If you were to work backwards. So what we're going to do with our problem, because I noticed those C's, is we're going to go backwards distributing. We're going to take these C's out, right, together, bring them in front, and then have the A plus B left there on the inside of the parentheses. Now, the parentheses are very important because that's the only way we're able to really combine the C's into one C. Because this says that C is going to be multiplied twice. C times A, which would make that, and C times B, which would make that. But I don't have to write the C twice. I just have to take a C out, put it in front of the parentheses of the terms that it was multiplied with. So it's backwards distributing. It's anti-distributing, as I called it earlier in class. So now that we've done that, right, now we only have only one type of C in this problem, right? You don't see 2 C's anymore. It's just one C. Now this says C times those parentheses, right? That's C times the parentheses A plus B. So since I'm multiplying this to C, well, then the opposite, because I want all of this to go away, right? The opposite of multiplying it to C would be dividing it. So if I divide by that whole entire group that's getting multiplied with C, then that whole entire group will go away. And I'm doing this because they're in parentheses. I can't do this if they weren't in parentheses. Remember, the parentheses are necessary here because it's the anti-distribute. The parentheses are there because of the distributive property. So because A plus B is grouped together, I can take them out together. So I'm dividing by A plus B, and I'm going to do the same thing over here, because if I do it to one side, I have to do it to the other. And there's my answer. Because these are going to cancel, I'll just have C on the left side, and it'll equal the 36 and divided by the A plus B. Okay. Now, you don't necessarily have to use the parentheses in the answer, because the parentheses are really only important if you're multiplying that group with something. Like here, I was multiplying the parentheses with C, which is why I kind of needed the parentheses there. But here, these aren't getting multiplied with anything, so you can just kind of take the parentheses off. All right, but there's your answer. It's a very interesting, unique step. We haven't really talked about something like that before. We have talked about the distributive property, but we haven't done the distributive property backwards before. So that's kind of unique. All right, so let's look at this one. We're going to solve for Z. We have W plus Y over Z. So similar to what happened earlier in the density and volume problem is here the Z that we're trying to solve for is in the denominator. I can't get rid of W plus Y at this point because I can't leave Z in the denominator. So my first goal is to get Z out of the denominator. And the only way to do that is to multiply both sides by Z. And it's multiplying because being in the denominator means it's being divided. And the opposite of being divided is being multiplied. So we're multiplying by Z so that I can just cancel it out. Now, on the right-hand side, canceling out the Z's, just leave us with W plus Y. And on the left side, I have Z times Y. Remember, my goal is to solve for Z. So now that it's on the left side, all I got to do is get rid of this Y. Since that Y is being multiplied to Z, I will divide by that Y so that I can cancel it out. So you can see the Z is over here. It's now all by itself. I kick the Y out, and it equals that, the W plus Y over Y. And I want to point out again, just like I pointed out earlier with the density volume problem, is if you look at the original problem, the Z and the Y have essentially only just flipped roles. And they flipped roles because, again, we did the opposite things. We multiplied by z, then we divided by y. So we did opposite things to these two letters, these two variables, and so they just kind of reversed places. That's just going to happen a lot of times in these problems. When you're doing that, when you're trying to get rid of things in the denominator, you'll notice that happening. I just want to point that out. So 5b equals d plus f over c. And we're going to solve for c. So c is very similar to the z in the last problem because it's in the denominator. So just like before, we need to get c out of the denominator. Denominator, again, means dividing by c. So we can multiply by c to cancel it out. But don't forget to do it on both sides. So we'll have c times 5b on the left. And on the right, the c is gone, so it's just d plus f. Now, because I'm still trying to solve for c, I need to get rid of 5b. 5b is getting multiplied to c, so if I divide by 5b, then I'll cancel it out. So I'll divide both sides by 5b, and I'll have c equal to d plus f divided by 5b. And I want to point it out one more time. The c and the 5b essentially just flipped roles here. And that happens when you have that denominator problem. The fact that our variable we needed was in the denominator to start with, you'll notice that happening. So I just want to point that out so that you see it in the future. Okay, so solving for h. These are the last two problems that we're going to work on. I want to make sure I show you this fraction. So we're solving for h, which means we need to get rid of b and 1/2. But really, we really don't need to get rid of 1/2. We just really need to get rid of 2. If I leave the 1 here, it's not going to be a problem because it would just be 1 times BH, and 1 times BH is the same thing. It's just 1 BH. So there's no reason really to get rid of the 1. It's kind of pointless. So what we're going to do is just get rid of the 2. Because the 2 is in the denominator, remember, in the denominator means it's being divided. So to undo that, I have to multiply. So by multiplying that side by 2, I have to multiply the other side by 2 because, again, you have to do the same thing on both sides. That 2 on the right will cancel with that 2 on the bottom, right? These 2's will just cancel each other out. So you're just left with 1 BH, or essentially just BH. And on the left side, you have that 2 over there now. You got the 2y. So we're still trying to solve for h. Since we're multiplying by b, we'll just divide by b. We'll have the h by itself. Don't forget to divide by b over here. We have 2y over b as our answer. So h is equal to 2y divided by b. And that's it. So now let's do our last problem. We have a plus bc minus dc equals e. So we're solving for c. So again, I have two c's, which is a problem. I'm going to have to combine these c's to one c, but I can't combine these terms together because they're not like terms. But before I deal with those c's, let's go ahead and move a. Since it's a positive a, we're going to subtract a on both sides. That'll just get rid of it and move it over here on the right. So we're going to have still bc minus dc, but equal to e minus a. So now, similar to a problem we saw earlier, right? We had those c's, two separate c's. We took them out. We did the anti-distribute. We did backwards distribute. We took them out of those terms, put that c in front, and had the a plus b left over. Now, this is actually called factoring, but we'll leave that for another day, that terminology. So we see the c's here. I'm trying to solve for c, so I need to take those c's out, bring them together, and then leave the b minus d in those parentheses. So I'm doing backwards distributing because let's pretend that I go from here to here, right? What I would do is I would do c times b, which is b times c, and I would do c times d, which is d times c, and I would get that same thing I had. So that's just something I do to make sure I've done this correctly. Is I look at distributing and have, if I do my distributing, is it the same thing I started with? Because obviously I'm backwards distributing, a lot of mistakes could occur. But we've done this properly. I've taken the C out, I've moved the C to the front, and I left the B minus D behind together in the parentheses. Now, this parentheses, B minus D, that's grouped together, and that group is being multiplied to C. So since I want to get rid of that group and it's being multiplied, I'll do the opposite, which is divide. I'll divide that group so that I can cancel that group out and leave just C. But of course, if I divide it, I have to do that division on both sides. So my answer, C equals, let me put over here, C equals E minus A over B minus D. That is my final answer. So be very, very careful of the anti-distribute step. It is technically factoring, but I'm just going to call it anti-distribute so that you get the idea that it's distributing but backwards. If you know how to distribute, which a lot of you already do, then just think about how that would work in reverse. That's exactly what we're doing here. All right. So guys, that'll be it. I'll see you guys in another video later. All right. Bye.